All right, I told you guys I'd do a couple of these questions on the back of that first handout of notes from Tuesday. Um, so that first one was 7x plus 13 equals 2 times 2x minus 5 plus 3x plus 23. Okay. Generally speaking, most people are going to, when you see the distributed process here, just kind of multiply that through. So we get that. Then the next thing usually that creates kind of efficiency in solving these equations is to combine like terms. So I'm going to take the 4x and the 3x. Remember, I'm taking the signs in front as well. I'll combine those. I'll combine the negative 10 and the 23. So those are things that can be combined on that side. But on this side here, those are unlike terms, so they just stay 7x plus 13. So then on the right-hand side, I got 7x. And then negative 10 plus 23 does give me then the 13. And at this stage, you see at this side here is the same as that side, so you could stop, and because this is an identity, okay, if you remember that from the first page, when the left-hand side is always going to be the right, no matter what I choose for x here, I'm going to get the left-hand side to be the same as the right-hand side. But you could go further if you want to. You subtract 7x from both sides and give you 13 equals 13. And you could stop there and say, well, yeah, 13 is always equal to 13. It's an identity. Or you could then go further and say, I want to subtract 13 from both sides, and I get 0 to 0. And that's kind of the last thing you could do or would want to do. Once you get to 0 equals 0, definitely don't go any further than that. But it is an identity question, which means if I were to graph this, those two lines are, this line here and that line there are identical to one another. They overlap each other all the time. Another one was, I guess question 2 is 2x over 3 is equal to x over 6 plus 1. This is just another linear equation. Some of you might prefer to write this as 2/3 times x equals 1/6 times x plus 1. You might see that from time to time. Those are saying the exact same thing. When we have stuff like this, we want to multiply by the LCD, the least common denominator. And essentially what that means is we want to be able to multiply by something so that we can make each one of these denominators grow to the same amount. Well, if I look at 3, 6, and that denominator of 1, I should be able to make every one of those denominators through multiplication grow to 6. Okay, so 6 is going to be that LCD that I want to use. So I'm going to multiply every single thing by 6. So I'm going to multiply that by 6, multiply that by 6, multiply that by 6. So when I do this, what really happens is when I multiply by 6, I'm really multiplying by the fraction 6 over 1. And multiplying fractions is you multiply the top times the top and the bottom times the bottom. So it gives you 12 over 3. Well, 12 over 3 simplifies to 4. But a lot of times what we do is kind of circumvent that work, and we write it this way. We'll say, okay, 6 and that 3 have a common factor, and then it leaves us 2. So now we take 2 times 2x, and it gives you 4x. Here, we're going to get that 6 and that 6 to have common factor, which would give me 1 then, eventually. And hopefully that makes sense. 6 times x over 6. Okay, or come over here and take 6 times 1/6. 6 1/6s give me one whole thing. And then plus this 6 times the 1 gives me 6. So now I'll subtract x from both sides, get 3x is equal to 6. X then ends up being 2. Now I can do, if I wanted to double check to make sure this is all correct, I can take this x and plug it back in, make sure I get the same thing on both sides of the equation. So I get 2 times my x divided by 3. So that's plugging into this side here. I'll have 2 over 6 plus 1. So this is 4/3. This is 2/6 plus, now 1 is the same thing as 6/6. So now that's 4/3 is equal to 8/6, but 8/6 reduces to 4/3, so this is 4/3 equals 4/3, so that is the true statement. That is the right answer. Question 3 was x over 2 minus 1/10 equals x over 5 plus 1/2. This is the same concept. I want to see what I can make each one of these denominators grow to. So it looks like 10 is the biggest, so I can make 2 grow to 10, I can 5 grow to 10, so I should be able to multiply everything here by 10. So multiply by 10, 10, 10, 10. So I multiply this by 10, I get 10 over 2, which obviously cancels out, gives me 5, so 5 times x then. Those are going to cancel completely, leave me with basically 1 times 1, which is just 1. Over here, that and that will cancel, leaving me 2. So I get 2 times x. And now that and that cancel, leaving me 5, so I get plus 5. Again, subtract my 2x from both sides, so I get 3x. I'll add 1 to both sides at the same time, so I get 6. X ends up being 2. And again, if you find the need, you can plug that back in and convince yourself that 2 does work there. The next one was 3x plus 1 over 3 minus 13/2 equals 1 minus x over 4. Okay. So now I look at these. Okay, 3, 2, and 4. Okay, I can't make them all go to 4. 4 is the biggest number here. So let's see if there's anything common. So the way you do this is you take every single term, every single factor that's in the bottom, and you use it. Okay, so I know I'm going to need a 3 for find my LCD. I know I need a 3 because of that 3. I know I'm going to need a 2 because of that one. Okay. Now, so if I use 6, here's the thing, guys. This is kind of what we talked about in class. If I use 6 here, here, and here, it's fine for getting rid of these fractions, but it's not going to cancel and get rid of this entire fraction over here. Okay. Because what happens is that there's a factor of 2 in both these, gives me 3 there, but then a 2 there. So I still get the denominator here, so that's a problem. So I need, even though I've already got a 2 in here, I need another 2 that comes from there. So I need that 2 there. And this is kind of what I was talking about in class, is the fact that 4 is the same thing as 2 squared. So when I'm trying to choose these denominators for my LCD, which factors need to be part of my LCD from the denominators, I choose all of them that are basically new. So obviously first one, 3 is new, I need that. 2 is new. But now there's a 2 here, and there's a 2 squared there. This 2 has an exponent of 1, this one has an exponent of 2. So which one do I take? I always take that one. Take the one with the largest exponent. So I multiply that together, it gives me 12. And hopefully then it kind of makes sense to you that, yeah, I can make each one of these things grow to 12 through multiplication. If that escapes you, if you have trouble with that, that's okay. Hopefully you can eventually wrap your mind around it. But an alternative way of finding a denominator that you're going to use, or I guess a common denominator, is just to multiply all of them together. Okay? So if I multiply all those, it gives me 24. It's not the LCD. LCD is 12, but 24 will still work. Okay? So multiply everything by 24, you'd be okay here. I'm going to use the 12. So 12, 12, 12. So those are going to cancel, leave me a 4. Okay, so now I have 4 times this thing, and it's a quantity, so you have 4 times that whole thing. So 4 times 3x gives me 12x, and then 4 times 1 gives me 4. Now here, these are going to cancel, gives me 6. Okay, so 13 times 6, I believe that's, so it's 78, so minus 78. And now here, that and that are going to cancel, leaving me 3. So now I got 3 times that quantity, so give me 3 minus 3x. I'll add 3x to both sides, so we get 15x over here. I'm going to take these two things, and if we combine them, that's a negative 74. I'm going to add that to both sides, so it gives me 77 over here. So now I divide both sides by 15 and get x equals 77 over 15. Okay, the last one here is 1 over x minus 1 minus 1 over x plus 1 equals 2 over x squared minus 1. Now, these are usually the ones that are a little bit more difficult because these things are the factors, okay? They're quantities, so put them in parentheses. It makes things a little bit more obvious. We need, when we come up with the LCD, we need all the factors here, okay? So I'm going to write this as, 1 over x minus 1 minus 1 over x plus 1. When you do these, you're always going to need to make sure that these factors are all factored, okay? So x squared minus 1 is a difference per squares, so we're going to write that this way. So now when I go through and I want to find my LCD, I'm going to multiply everything by, I take everything that's new, so I know that x minus 1 has to be part of it, okay? I go to this one here, and x plus 1 is something new, so that has to be part of my LCD. And now I come to here, well, x minus 1, I already got that right there, so it don't have to be added. And I go to this one, x plus 1, well, I've already got that here, it doesn't need to be added. So here's my LCD. Multiply every single thing by that. So x minus 1, x plus 1, x minus 1, x plus 1, and then here x minus 1, x plus 1 again. Those are going to cancel, and now you're left with x plus 1 times 1, which is just x plus 1. Over here, these are going to cancel, okay? So now here's the only thing. You're left with, it's a negative 1 times this thing. So it's negative 1 times x, which is just negative x, and then negative 1 times negative 1, which would be positive 1. Just be careful with that. And then over here, we get those to completely cancel out, and leaves me just 2. So now we get the x's to drop out. You're left with 2 is equal to 2. This is a true statement. So what that tells me is that these two things are kind of the same, okay, graphically.